This is one of a number of videos we're making, just recapping on straightforward processes and methods in arithmetic and algebra, the type of material you will have covered at school. But perhaps, as I say in other videos, that may have been some time ago. So now you're about to take on one of our courses, just worth perhaps bringing it all back to mind. It's not that you're going to use perhaps a lot of arithmetic or algebra or whatever in our courses, but it's just bring it all back. Bring back the student days, and bring back when you were at school, and just refresh the parts. If you're already up to speed, if you're already happy with what you know and you don't need this, please just turn it off and do something else. This is just meant to be a basic run through of very straightforward principles. Today we're going to look at exponents. Now some people may find these a little obscure, but very straightforward to deal with, and it's worth knowing about them. It's just another piece of knowledge that is just good. It's good to know it and good to be able to use it. So let's look at exponents. Now it's quite a short video, so we should get through it fairly fast. If we think about a number, any number, say 2, just 2 on its own, 1, 2, 3, 4, just 2. It's actually 2 to the power of 1. Now what I mean by that is it's 1, 2. It's 1, 2. It's 2 once. It's doesn't sound right when we say it like that. It sounds a little crazy, but 2, 1 is 1, 2. Better move on and let's look at it. Just expand this idea. It might become a bit clearer. Just for the moment, we say that 2 to the power of 1. The little 1 on the top here. I just put the cursor on the screen. My straightforward little cursor. See the little 1 on the top. It means 2 once. So it's just 2. The 1 doesn't do anything to it. It's like counting 1, 2, 3. It's just 2. So 2 to the power of 1, we say. And this little 1 here is known sometimes as the index number or the power number. We just write 2 to the power of 1 is 2. But if we have 2 squared, we call it, when it's to the power of 2, it's 2 squared. Now we've got 2 2's. So the little 2 tells us we've got 2 of these. That means we've got 2 times 2. So 2 to the power of 2 is actually 2 times 2. It's 2 twice. This idea I started with, which sounded a little mad, has become easier to understand. The little number on the top, the index number, this little 2 up here, that 2 means we've got 2 of them. They're multiplied 2 by 2. So 2 squared, as we say, when we get it to the power of 2, we call it squared. 2 squared, or 2 to the power of 2, is equal to 2 times 2. 2 to the power of 1 is just 2 on its own. This is one of the 2's. Here there are 2 of the 2's. So 2 to the power of 2 is just known as 2 squared. Anything to the power of 2 is called squared. Three 2's. Well, 3 2's is 2 times 2 times 2. And the exponent here, exponent, the power number is 3. So it's 2 to the power of 3, which is 2 times 2 times 2. There are 3 2's involved. They're multiplied together. There are 3 of them. 1, 2, 3. 2 times 2 times 2. 2, 3 times. So we've got that. Now, this number over here, I'm just here working up from 2 to the power of 1 is 2. It's just 2 on its own. 2 squared, 2 to the power of 2 is 2 times 2. Go back up here. 2 to the power of 1 is just 2. 2 squared has got 2 of them. 2 cubed. When you get a number to the power of 3, we call it cubed. So 2 to the power of 3, or if you like, 2 cubed is 2 times 2 times 2. We've got 3 of those. So 1, 2, 3. And look at the exponents. 1, 2, 3. So 3 cubed is known as, 2 cubed, 2 to the power of 3 is known as 2 cubed. I already mentioned that. Now, 2 to the power of 1 times 2 to the power of 1. That's equal to 2 squared, which is equal to 2 times 2, which is 2 squared. We just have 2 multiplied by 2, which is 2 to the power of 2. We've got 2 of them. So now we're getting an idea of how to multiply these things together. If we have 2 to the power of 1 times 2 squared, we have 2. That's 2 to the power of 1, just there. So that 2 on its own is the same as this 2 to the power of 1. Times, there's the times again, 2 squared. That means 2 times 2. There it is, 2 times 2. Now, if you multiply that, you can see it's actually 2 times 2 times 2. It's 2 3 times. And there it is, 2 3 times. 2 cubed. So 2 to the power of 1 times 2 to the power of 2 is equal to 2 to the power of 3. If you add that exponent, that index number at the top, that power number, 1, if you add that to 2, you get 3, which shouldn't surprise us, because 2 plus 1 is 3. Anyway, let's have a look. So there's a pattern emerging here. 2 to the power of 1 times 2 cubed, 2 to the power of 3. Well, you've got 2 to the power of 1 is just 2, times 2 to the power of 3 is 2 times 2 times 2. It's 2 to the power of 3. And that's equal to 2 to the power of 4. 1, 2, 3, 4. 2 to the power of 4. In other words, 1 plus 3, 1 plus 3 gives us 2 to the power of 4 over here. So if I just write it down here, I've got 2 squared times 2 to the power of 1. So I'm writing 2 squared in brackets here. It's 2 times 2, 2 squared, times 2 to the power of 1, which is just 2. And that equals 2 to the power of 3. 2 squared times 2 squared is 2 times 2 times 2 times 2. That's 1, 2, 3, 4. 2 to the power of 4. So you can see that 2 squared times 2 squared is equal to this times this equals 2 to the power of 4. In other words, add the 2 and the 2. 2 squared times 2 to the power of 3 is 2 squared inside the brackets here, 2 times 2, times 2 cubed, 2 to the power of 3, which is 2 times 2 times 2, 3 of them. And that equals 2 to the power of 5. 1, 2, 3, 4, 5. 2 to the power of 5. In other words, 2 plus 3. So those are our numbers. That's the way it works. And you can now see that when you multiply numbers with a common base, 2 is the base here, the index number is 2, or the exponent, same meaning. The index or the exponent is 2. Here the base is 2, same base, it must have the same base. This only works if you have the same base. So we have 2 and 2. The exponent here is 3. So 2 to the power of 2 times 2 to the power of 3 is 2 times 2 times 2 times 2 times 2, which equals 2 to the power of 5. And you can see what we've done here is we've added the 2 and the 3. So when we're multiplying numbers with the same base and we have these exponents, we just add the exponents together. If you're dividing, it's just going the other way. If we take 2 squared, it's 2 times 2, divided by 2 to the power of 1, which is just 2. Well, one of those 2's cancels with one of the 2. The 2 on the bottom cancels with one of the 2's on the top, leaving us just 2. In other words, 2 to the power of 1. So 2 squared divided by 2 to the power of 1 equals 2 to the power of 2 minus 1. 2 here, take away the 1 underneath, take it away, which leaves 2 to the power of 1, which equals 2. And if you want to check that, you can just simply say 2 squared is 2 times 2, 2 to the power of 1 is 2, like we have here. One of those cancels, leaving us 2. So index numbers are actually quite straightforward, providing you remember when you're multiplying, you add, providing the bases are the same. Here the base is 2. The base could be 6, or it could be 1,000,000, or it could be whatever. We often use, in calculations, we often use the base 10, because we like 10. 10 is the basis of the decimal system. And we tend to like 10. There are other numbers we like as well, but in this case 2. So we can see what's happening. If we're multiplying and we have the same base, we can add the exponents. If we're dividing, we can subtract, and that's the logic. This line here, if you work carefully across that line, you'll see exactly how this works. 8 over 2 is equal to 2 times 3 over 2, not 2 times 3, it's 2 to the power of 3, I beg your pardon, 2 to the power of 3 over 2 to the power of 1, which is equal to 2 to the power of 3 minus 1, which is equal to 2 to the power of 2. Take away the 1 from the 3, leaves us a 2. And 2 to the power of 2 is just 2 times 2, and 2 times 2 is 4. In other words, 8 divided by 2 is 4. Except on this particular case, we've just taken a journey. We've taken a longer journey. We decided to do it with exponents. But we get to the same answer, except we've gone down this different route. But it's nice because it confirms to some extent in our minds that what we're doing here is correct. It's a check on us. Eight divided by 8. Well, we can write that as 2 to the power of 3 divided by 2 to the power of 3. In other words, 2 to the power of 3 minus 3. Take away 3, because we're dividing, so we take it away. Well, 3 minus 3 is 2 to the power of 0. That must equal 1, because 8 divided by 8 is 1. So 2 to the power of 0 is equal to 1. And that's an interesting situation, because it means that every time we see a number to the power of 0, no matter what the number is equal to 1. So any number 10 to the power of 0 is 1. 200 to the power of 0 is 1. Any number to the power of 0 is 1. So that's quite interesting. 2 to the power of 0 is 1. Any number to the power of 0 is 1. X to the power of 0 is 1. Look at this. 2 times 2 equals 4, equals 2 to the power of 2. Four times 4 equals 16, equals 4 to the power of 2. 4 is multiplied by itself. That's what the squared means. It's 4 times 4. 4 is multiplied by itself. 3 cubed is equal to 3 times 3 times 3. There are 3 of them multiplied. That's 3 3s 9, 3 9s is 27. So 3 to the power of 3, 3 with the exponent 3, is 27. Now look at 5 squared. This is called 5 squared, or 5 to the power of 2. We say to the power of 2, or the exponent is 2, or the index number is 2. It's all the same thing. So 5 to the power of 2, actually that equals 25. It's 5 times 5. 5 to the power of 4, this is called 5 to the power of 4. That's all you got to remember. Look at that number and just call it out. 5 to the power of 4. In other words, it's 5 times 5 times 5 times 5. It's 5 multiplied by itself 4 times. 5 times 5 times 5. There it is. 5 times 5 times 5 times 5. So there's 4 of them. That equals 5 to the power of 4. So you can write any number like this and any exponent. And if we see something like this, we can easily go back and write it down like that if we want to. Make it easier. So going back to it, 5 to the power of 4. If you look at this exponent, that's the 4. It's also called an index number, or it could be a power. 5 to the power of 4. That's what we normally say, in fact, 5 to the power of 4. We don't normally say 5 to the power of 2. We'd say 5 squared. It's just language. It's not really mathematics or anything. It's just the way the language is. That's the way we speak. But all I'm saying here in this slide is that that has got different names. And if you see a different name, that's all it means. Here's something you should note. Evaluate 2 times 3 cubed. This is not 6x cubed. We do not multiply the 2 and the 3 to get 6 and then cube it. This 3 cubed has to be done first. This is important. Note this carefully. When we have a power number like this one, 3 to the power of 3, we must do that calculation first and then multiply it. We do not go 2 times 3 is 6, 6 cubed. That's the wrong answer. Do the exponent first. So in other words, we get 3 times 3 times 3 times 2, which is 54. Whereas this is 6 times 6 times 6. Let's do that again. Let's evaluate this one. Evaluate means let's reduce it, get it down in size, see what it's really equal to. So we've got a bracket here. We've got 3 plus 2 cubed times 2 minus 4. Well, evaluate the inside the bracket first. These are our rules. Whenever you see a bracket, do inside the bracket first. Work from the inside out. So start on the inside. And when you start on the inside, the first thing you do is evaluate this exponent here. Evaluate this term, 2 to the power of 3, 2 cubed. Work that out first. And 2 cubed is just 8. It's 2 times 2 times 2. 2 times 2 is 4. 2 times 4 is 8. So now we've got, inside the bracket, we've got 3 plus 8 times 2 minus 4. So work out inside the bracket again. Just carry on working inside the bracket, because nothing else is touching that. That seems to have a life of its own. That works on its own. So 3 plus 8 is 11. Now we've got 11 times 2 minus 4. There's the times 2 minus 4. There it is again. So we just drop down. We've got 11 here. Now our rule is, from previous videos, multiplication and division must be done before addition and subtraction. That's our rule. So we do not subtract this first and then multiply it. We don't say 2 minus 4 is minus 2, minus 2 times 11 is minus 22. That's the wrong answer. No marks for that. Follow the rules. The rules are multiplication and division must be done before addition and subtraction. Here is multiplication, here is the subtraction. So do the multiplication first. So 11 times 2 is 22. Now take away the 4, giving us 18. So this expression up here can be reduced down to 18. That's the answer. So that's a short, very short video on exponents or index numbers. Worth bearing in mind. You might never encounter it again. You might in the course of your studies. But if you do, it's there, or you can at least look it up and see what it's about. But that's all we're going to deal with this, so let's leave it at that and say thank you for watching.